This video will cover the Common Core Geometry exam from June 2015. We're going to start with this video on questions 1 through 5, and in each question I will be giving a thorough explanation as to how the answer is found. That way if you get stuck, you'll be getting notes at the same time while watching the video. Question 1 says, which object is formed when right triangle RST, shown below, is rotated around leg RS? So here we are going to rotate around leg RS. We have the options of 1, a pyramid with a square base, 2, an isosceles triangle, 3, a right triangle, and 4, a cone. When we rotate around a line segment, we know that we go from a 2D shape to a 3D shape. So here I can immediately cancel out choice 2 and 3 because triangles are just 2D shapes. Whereas a pyramid or a cone are 3D shapes. Again, when you rotate around a line or a segment, you end up going from 2D to 3D. If you rotate around just a point, like on a graph, then you just stick with 2D. When thinking about this question, we really have to visualize what's happening here. We have to take this triangle and rotate it around line segment RS. And so I'm going to try and sketch what this would look like if we were to rotate around a segment. So we start with this triangle RST. And I know that I have a right angle here. Because I'm rotating on this line, any point on that line is going to stay just where it is. But any point outside of the line, like point T out here, is going to actually rotate around this line segment. And I have to make a full circle here because I'm rotating 360 degrees, rotating continuously around segment RS. So when I do that, T gets moved to all of these different places around the circle at each point or each degree of the revolution. When I do that, RT is actually becoming a bunch of new segments. So RT now is out here, it's out here, it's out here, where this base is a circle. And I have RT now becoming many new line segments along this circle, connecting from vertex R to the edge of the circle. And if you think about this shape, it's a circular base with a triangular top or triangular bottom if you were to flip it upside down, and that shape is in fact a cone. Now, it depends on what shape you're looking at originally to figure out what kind of figure you get. Because we started with a right triangle, we end up with a cone because when T again gets rotated around, it gets rotated in a circular fashion. If you have a different figure to start, such as a rectangle, being rotated around an edge again, this figure would still create a circular base going around, but this time, because it's a circular base going straight up and down, we end up with a cylinder. So again, if we start with a rectangle, we end up with a cylinder. If we start with a triangle, we end up with a cone. If you start with a circle and you rotate around a line segment through it, you end up with a sphere. Now I know that this is kind of tough to understand, and I think I found a website that does a great job of explaining it, so I'm going to pull it up here below. Oh no, it's all under my writing. Okay, so I've brought it to the front, and if you go to the website you can see here https://learnzillion.com. There's actually a lesson code that we can type in here where it says search or enter LZ code. Go ahead and type in 7269. Again, that's where you search for the LZ code, 7269. And hit search. Then it says that we have one result, identify the shapes of a 2D cross-section, blah blah blah. So we're going to click on that. Then we're going to scroll all the way to the last lesson that you see here in green, predict 3D results of rotating simple figures. You should not have to log in. It must be because I've visited the page so many times. If you want to create a free account, then you're more than welcome to. All you need is a first and last name, email address, and then a password. But what you'll do, I'm not sure if I can get beyond this at this point, but what you're going to do is hit begin lesson, or the next button that you see down here underneath the page, hit next, and then you're going to watch the video, and the video does a great job explaining and showing you a rotation around a line segment. So again, this is just a great website to help you figure out or understand better rotating around a line segment. Okay, so at this point I'm going to move on to the second question. Let me just delete this web page now. So the second question says the vertices of triangle JKL have coordinates JK and L, under which transformation is the image of JKL, and all of those are primes, not congruent to triangle JKL. So in order to not be congruent, we have to have different side lengths. So each of these choices 1 through 4 have different transformations that are performed. A translation is a slide. So when I slide a triangle from here to, say, over here, the side lengths remain the same size. So 1 is not our choice. Number 2 talks about a rotation of 180 degrees. A rotation is just a turn of an object. So again, if I start with the triangle here and I just turn it 180 degrees, obviously that's not a great sketch there, but if I rotate, the object still stays the same size. So rotation is not going to create triangles that are not congruent. The next one says a reflection. If I take this, again, original triangle, and I reflect it over the x-axis, it lands here. A reflection, or in other words, a flip, creates congruent triangles. The side lengths are the same. The next one says a dilation. A dilation is a grow or a shrink, and in this case it's going to be a grow because the scale factor is greater than 1. If I start with my original triangle and I dilate by a scale factor of 2, it grows, and so now the triangles are different sizes. This one side length is not congruent to the corresponding side length. So choice 4 is our answer. Moving on to question 3. Says the center of a circle Q has coordinates of 3, -2. Now if you have graph paper, I would suggest that you plot these points as we read them. I'm just going to sketch my own graph off to the side here. So I have 3, -2, and that's point Q. And the circle Q passes through R at 7, 1. So I have 3, 4, 5, 6, 7, and up 1. What is the length of the diameter? So what we're saying here is we have Q as the center and R as a point on the circle. So that means that QR is the radius. But we're asked to find the diameter, and we know that diameter is twice the radius, 2r. So if we find the length of QR, or in other words the radius, then we just have to double that in order to find our final answer. In order to find radius, we're going to talk about change x, change y, and then plug those values into the Pythagorean theorem. This is the same as using the distance formula if you are familiar with that, but Pythagorean theorem just seems to be an easier option to plug into for students because you use it for so many years in a row. So change x, this delta x, means to subtract x values. So I'm going to start with 3 from Q and take away 7 from R. 3 take away 7 is -4. Because I started with 3, I now have to start with -2. That's the y value that matches with the 3. So -2 take away 1. -2 take away 1 is -3. When we plug into the Pythagorean theorem, the change x is going to go in for A, and the change y is going to go in for B, and our goal is going to be to solve for C. Because we plug into a squared function, I can ignore the negatives. So now we have 4 squared plus 3 squared equals, I'm going to say r squared because C is going to represent the radius r. 4 squared is 16 plus 3 squared is 9 equals r squared. 16 plus 9 is 25, still equal to r squared. Now in order to get r by itself, I need to square root both sides. So now my radius is equal to 5. Or in other words, QR is equal to 5. But remember that we cannot choose that as our final answer, nor can we choose 25, because that was r squared, nor can we choose 50. So it looks like we're left with 10. And remember that diameter is equal to 2 times the radius. And here again we found radius is 5. 2 times 5 is 10. So we should end up with choice 3. So again, the answers for this page here, number 1 is 4, number 2 is 4, and number 3 is 3. Question 4 says, in the diagram below, congruent figures 1, 2, and 3 are drawn. Which sequence of transformations maps figure 1 onto 2 and then 2 onto 3? If we look at these figures, we want to figure out what keywords are being used here, like flip, slide, turn, or grow/shrink. Because these keywords help us figure out what transformations are being performed. Remember that a flip is a reflection. A slide is a translation. A turn is a rotation. And a grow or shrink is a dilation. So when I look at these figures, I notice that they take point A, they move it to the right, and then they move it up. If they're simply moving, it looks like a slide or a translation is being performed. So first we slide, or in other words, translate. Then secondly, when we look at this, it looks like now we take A prime and move it all the way over here to A double prime. We take B and do the same thing. We move it, we turn it. Notice again that this figure is being turned. It's pretty vertical right now, but when we look at the double primes, it's more horizontal. So secondly, we are turning, or in other words, rotating. So our choice here should be 4. Question 5 says, as shown in the diagram below, the angle of elevation from a point on the ground to the top of the tree is 34 degrees. So angle of elevation means look up. And it says from a point on the ground. So we look from the ground up to the top of the tree is 34 degrees. If the point is 20 feet from the base of the tree, so 20 feet from the base of the tree, the bottom of the tree to the point is 20 feet. What is the height of the tree? So my goal is to figure out this height here. So I'm going to choose to call that x. Notice how we marked up the figure as we read, because we had a lot of important information to figure out and mark up on the diagram in order to figure out the answer to this problem. Because I have 2 sides and 1 angle, this tells me to use trig. So, ka, to, Okay, so I just said SOHCAHTOA. Well, that's a pretty weird phrase, but it really helps you to remember when you use sine, when you use cosine, tangent, and then opposite, adjacent, and hypotenuse. S means sine, and so we know sine uses opposite over hypotenuse. C means cosine, and that uses adjacent over hypotenuse. Tangent is T, which uses opposite over adjacent. So when I'm looking at this picture, I start by circling the angle, and then I label the sides that we have as H, O, and A. Opposite the angle is X, so that's an O, opposite. Next to the angle, I have a 20, so that's A for adjacent. The longest side of the triangle, or across from the right angle, is the H, the hypotenuse. So I notice that I'm using an A and an O, which forces me to then use TOA, or tangent. So now I have tangent of the angle, 34 degrees, is equal to opposite over adjacent, x over 20. When we have a proportion, it's very helpful to put the non-fractional side into a fraction form. So just dividing by 1 would keep it the same. When we have a proportion, we get to cross multiply in order to solve. 1 times x is equal to x. And now I have 20 times tangent of 34 degrees. If you're using an old TI 83 or 84 calculator, you need to make sure that your calculator is in degree mode by hitting mode and then go down to where you see degrees, then hit enter. If you're using a TI Inspire, these are already in degree mode, so you don't have to worry about doing that. So now all you need to do is type this into your calculator. 20 times tangent of 34 degrees. Make sure that the 34 is in parentheses, otherwise you're going to get the wrong answer. When we type it in, we end up with x equals 13.4902. But because it's asking us to round to the nearest tenth of a foot, here's my tenths place with the 4. Look to the right, 5 and above, give it a shove, 4 below, let it go. So the 9 is telling me to give it a shove. So now I have x equals 13.5, which is choice 3. So again, the answers on this page, number 4 is choice 4. Number 5 is choice 3.